dichrometry, but initially we will get the color red. Initially we will get the color red, but by the time we reach the endpoint, it will become colorless. And at last we have dichrometry, and initially the color which will be seen is green, but by the time we reach the endpoint, it was red color.
Have you understood the difference of endpoints here?
Yes, yes.
Right? So this is a very good demo showing the endpoint, because everyone will get confused. Right? So this demo was being very clearly indicating that what is the end point of a particular titration. Right? What will be the end point of a particular titration. Okay, so as previously he was explaining about iodometry and chromatometry, both was liberating iodine or chromium or halogen, whatever we can call it. Right? So while both was liberating a halogen, but both halogens having a different properties. Right? Are you clear about that? Right? So both having a different properties. So here also you can clearly see that iodometry means iodine will be liberated, so blue to colorless. But chromatometry was colorless to red color. Right? So you can clearly see the difference. But the principle how it will be acting was same. Principle between iodometry and chromatometry was same. Both will produce halogen. Iodine will be produced or bromine will be produced. But the end point different. That was very clearly explained in this particular demo. So you can check it out what will be the end point. Ready?
Good morning everyone present here. So today I am going to show you an example of redox reaction with bleach and food color. So when we add when we have food color and bleach. Okay. So when we add food color with bleach, what happened here is when we added bleach in this solution, it breaks down the colored compound in the coloring in the food coloring. In the food coloring, the colored part of the food color is oxidized by losing its color, and the bleach is reduced by losing its evaporator. Sorry, by gaining its evaporator. Thank you.
Everyone is showing there. Not you only.
This was a model of dropping in the electrode with a photography. It was a working electrode. It was invented by Charles in the year of 1922. It uses a dropping mercury electrode which acts as an indicator electrode. It's a cathode here and a pool of Hg. Hg is mercury, which acts as a reference electrode, acts as an anode here. That sliding contact is connected with the resistor. Conducting current was supplied here. Then the sliding contact gives
and voltage, and the curve is sigma curve.
This nitrogen input is used for expelling out oxygen.
In this case, there is an absence of oxygen. It involves nitrogen gas in it.
Or hydrogen gas. Nitrogen or hydrogen gas will expel out the oxygen out so that the reaction passes through. The advantage of
Fluid was potassium.
organic substance and are mostly used in pharmaceutical industry, and it's also disadvantage is very toxic because of use in mercury, and the capillary tube present is very thin, so it can be burst also.
And the indicator electrode is always used in inert gases like platinum or mercury is used in the indicator.
Or cadmium is
The droplet drops every 2 to 12 seconds. So per minute, 5 to 30 drops. Thank you.
So first of all, we will take hydrogen peroxide in a transparent water bottle, and then we are going to add baking soda into it. So as we add baking soda, the carbon dioxide will be released. This is due to the decomposition reaction of hydrogen peroxide and baking soda. So let's see how the bubble comes. So here you can see the effervescence, how the bubbles are released, and these bubbles are released due to the release of carbon dioxide, as we know that this is a decomposition reaction and it is also an exothermic reaction. So